here's the question about the two objects with the same acceleration. So here we go. We've got two objects, x and y. I've got, that have accelerate from rest. Okay, so that means v naught equals 0 with the same constant acceleration. So we'll call that a. All right, so over here, this is object x and this is object y. So v naught is 0 for both of them, and they have the same acceleration. We'll just call that a. Object x accelerates for this twice the time as object y. So we'll say the time for y is t, the time for x is 2t. Which of the following is true of these objects at the end of their respective periods of acceleration? Okay, so I didn't include the choices, but we've got either object x has traveled twice as far or 4 times as far as y. It has traveled the same distance as y, or it's moving 4 times faster than object y. All right, so what I'm going to do is just cross off some of these formulas. I'm going to cross this off for the distance. So we're going to talk about the distance first. So let's see. And we'll say that these two, this is x, this is y. We'll say that they both start at x naught equals 0. Okay, so I'll just put that down. And they go to the right. And that's positive. Okay, so if I want to talk about distance, I want to know what x is. I'm not going to use this first one. I might use this second one, but probably not. I might use the third one, but actually I can't because we don't know what v is. Actually, I can't use that middle one either. So I'm going to use this bottom one, x equals x naught plus v naught t plus 1/2 at squared. What we know is that x naught and v naught are both 0. Okay, so we're just going to say x equals 1/2 at squared. So for object x, I'm going to say x equals 1/2, and then a, we just wrote a, and t is 2t squared. This gives us x equals 1/2, and I'm going to leave this like this for sure, for a reason. So 2t squared is 4t squared. You square the 2 and the t. Okay, now I'm going to do a different one for y. For y, I've got, I have that x equals 1/2 at squared. The a is a and the t is t. So 1/2 at squared. When I compare these, right, I can rewrite this for x. I can take this 4 and move it out front. So I'll do that. I'm kind of out of room, but hey, whatever. Let me get rid of something. Let me get rid of this. Okay, so what I mean by this is I would do x equals 4 times 1/2 at squared. Okay, so this is for object x. All right, what you can see is that for object y, its final distance is 1/2 at squared. For object x, it's 4 times 1/2 at squared. So we know here that the distance, right? So we know this is 4 times the distance for y, object y, because it's 4 times 1/2 at squared. So we know that it's got to be the first option, that object x has traveled 4 times as far as object y. We know that the second option, that it's traveled twice as far, is not true, and the third option, that they've traveled the same distance, is not true. The only other thing we might want to check is what the final speed would be. And okay, so let's check what our final speed would be. And everything is messy now. So if I was going through this and I was trying to find final speed, and let's say I had done this kind of like at the start, right? Without knowing that object x travels 4 times as long as object y. So we're just using what we know in the table. We don't know v, we want to find that, but we don't know x. So anything that has final position, x, I'm going to cross out. So that leaves, actually that last one doesn't have x. And we want to find v, so we need to have v in it. This last one does not have v. So I'm going to use v equals v naught plus at. So for x, v equals v naught is 0, and then I would say a times t is 2at. For y, v equals v naught is 0 again, and at is just at. So we can see that x actually is only twice as fast as y is, right? So we're looking at, here's at, here's the at, so it's basically the object x is moving twice as fast as object y.